Assalamualaikum and very good evening to all. This is presentation for the group 3 for operation planning and control project, and our team member is Rutira, Vino, Samila, Hazika, Rishalini and me as a Faris. And our title for this project is production improvement at Sifa fabrication. Next. Okay, this is presentation outline for this project. For this presentation, we will go to first one is introduction by Samila, and then presentation for case study using OPC tool by Rutira and Vino, and then followed by problem statement, objective and scope by Vino and Faris, data collection, analysis and result by Faris, discussion, improvement proposal by Azi, and finally the conclusion by Rishalini. Next. Okay, this is the project Gantt chart for this project, and we start the progress for this project on 10th of December, and now to we presentation recording, and then after this we will followed by the presentation preparing the report to complete the task for this project. Okay, next. Okay, next presentation I pass to the Chamila to proceed.
Introduction. Operation planning and control follows the operation design because once a product or service has been designed, it needs to be produced. Operational planning and controls need to be established and implemented to enhance occupational health and safety, eliminate hazard, or at least reduce the occupational health and safety risks to level as low as possible for operational areas and activities. Then operation planning and control is concerned with ensuring that the day-to-day production process proceeds smoothly. Next. Then importance of OPC to demonstrate the OPC tool. First is individual can achieve a credible industry recognized accreditation, which in turn boosts confidence and status. Second is help the delegate to achieve mutual understanding of terminology that will be shared across the industry with colleges, customers, and suppliers. Important is help the team to understand and be able to develop their own scheduling guidelines and the various types. For example, guns and line of balance and time changes. Fourth is link project controls into the wider project management context. For example, trainers are experienced project managers as well as knowledgeable in project control area. The last important is delegate able to consider how to best use time cost, schedule visibility task, buffer, and different type of dependency within their schedules. Okay, next I pass to Rutira.
Hi everyone. Now I will be reviewing the first case study that we have here. So this is regarding a case study performed in soft drink manufacturing company located in South Africa. So the challenge observed in the company is they are nearly impossible to increase the productivity with their current settings. So they used productivity calculation as their tool to measure the improvement they are making in the company. So in this case study, they have calculated the single factor productivity, multi-factor productivity, and also the productivity index before and after the improvements are made. So this shows the first calculation, which is before the improvement made. So the output is 34,560,000, and the input is over 41 million rand, and the total resource productivity is 0.082 units per rand. So as part of this study, they made some improvements, which are, first of all, they removed the unnecessary working hours. The people who are not needed for 24/7 in the company were removed. So the second thing that they did was to increase the number of units produced per month by making some little adjustments in the machine setting. For example, they made the machine revolution from 40 to 50 bottles. So the third thing that they have done is they introduced use of natural resources, renewable energy, which is solar energy, to produce required energy for their production. So After all these changes made, they realized their output itself has increased, which is 39,744,000 units of product, and the input has decreased, which is 36 over million. Initially, it was 41 over million, and the total resource productivity has increased to 1.03 units per rand. So from here, they have calculated the productivity index, which shows all of the calculated values has increased from the uh, value before the improvements were made, except for one thing, which is the wrapping plastic, which is constant, and the total resource productivity also has increased. So I will pass it to Vino for the second case study presentation.
Hi everyone. This next case study will be in a manufacturing company named Masna Paper, whereby they started their new business with 45 employees. They're supposed to hire 75 employees, but then they only hired 45. So what they faced was machine and other necessary equipments were more than enough to handle the demands. Unfortunately, the lack of numbers in employees has caused them to being delayed in delivering their products. So the statistics shows in 2015 that 47% of their orders were not being delivered on time. And in 2016 till week 14, the percentage has been reduced to 39%, which is even worse compared to the previous year. So they still hold a very huge loss. So what the CEO of the company decided was to improve the delivery reliability up to 95%. Next. So what actually the focus was into the first point is low delivery reliability. Second is to improve on the inefficient production methods. And also the third one is to use manual compared to a structured planning. So the objective is to increase the delivery which all these three problems that they focus in actually solve their problem to 95%. And their rate of sending out delivery to the customers have increased. So next one. So in our case study, we have two problem statements, whereby the first one is what type of measurements are involved in determining the problem occurring in an organization from OPC aspect. And the second one is how a good selection of OPC tool can be selected and applied to help improve an organization. So I'll pass to Faris for the next slide.
Okay, please pay attention to the slide. Okay, this is our actual case study and the project selection. And the company we select is a Sifa Fabrication Malaysia's neighborhood. And this company is located in Johor Bahru. So for your information, Sifa is leading in technical fabric, which produce precision fabrics. And to summarize it, Sifa Fabrication is one of subsidiaries which focus on producing fabrication such as filter press, industrial belt, cut piece, and others. So at the right side, you can see the picture. This is picture the application of Sifa product is a filter press. And also we make an industrial belt for several applications in Malaysia industry. So our target for this project to reduce lead time and produce the fastest delivery to the customer, which means we want to make a customer satisfaction. And this case study will focus on improving this organization by several tools learned in our subject, operation planning and control. Next. Okay, this is situation in Sifa fabrication. This is three main problems that we're facing right now. The first one is high fabrication cost, which means that the fabrication cost getting higher from time to time, but it is very difficult for us. We need to increase the selling price if we want to get more profit. Nevertheless, if we increase more price, it will affect our market and we will lose it easily. And the second one is the higher lead time, which means that in order to expedite lead time, there is no compromise of skipping the quality control, which means that we need to follow any procedure by the quality team without skipping any procedure, and at the same time, we need to expedite the lead time. And the third one is the low capacity utilization. There is demand from the customer for producing high quality, but right now we have difficulty in terms of capacity. It is very low. So this is our plan to increase the capacity of the fabrication. Next. Okay, this is a project objective, which means the first one to develop strategies of reducing fabrication costs in order to improve productivity and profit. The second one to reduce lead time of fabrication process while maintaining the quality of product. And the third one to increase capacity of fabrication to higher quantity and meet customer demand. The scope of the project is limited to the company, which means Sifa Fabrication, Malaysia Sdn Bhd, and OPC tool used for this project are total productivity index and annual profit, process analysis and design, and utilization efficiency, and data used for analysis actual data from sales, database, fabrication costs, SOP, LN system, which is our system in the company, itinerary record, and others. Next. Okay, this is our data collection method, which means our priority is to focus on to meet satisfaction of the customer, which means the first one, fastest delivery, best quality, and affordable price. And the OPC tool, as explained previously, the data is collected for the first one, total productivity and profit collected from the sales database, because we want to measure the performance of organization, especially in production team. Okay, the next one, the process analysis and design. Actually, this data is collected from updated SOP of fabrication flow. And the third one is utilization and efficiency. The output is measured by routing and productive hours, and data is collected from company LN system, because we are using a system named LN. So, and then we also measure by the itinerary reports to analyze this activity. Next. Okay, this is our first tool we are using, which is a total productivity index and annual profit. It shows that between two different years, between 2022 and 2023. Okay, for the first one, we can see that there is total output is increasing from 2022 until 2023. At the same time, the input also without deflation is decreased, but with deflation is decreased, but without deflation is increased. So in the end, we can see that the total productivity index comparison between these two from the table, it shows that the productivity from 2022 is increased around 39%, and annual profit is increased by 173%. So this is because the total output for the 2023 is increasing a lot for that year. Next. Okay, this is the based on the second one is based on process analysis and design. Is our target for this table is to measure the time functioning mapping. So it shows that our order sequence from the customer until the logistics. So this analysis is important to measure our lead time of the fabrication from the receiving order until to the customer side, which means it takes around 15 days. Next. Okay, the next one is the utilization and efficiency. We want to compare between 2 years, 2022 and 2023. And we can see that based on utilization, we can conclude that utilization is reducing from 2022 to 2023 around 6%, and efficiency is increasing around 4%. Okay, based on suggestion or improvement suggestion on efficiency on 2024 around 80%. So the expected output will be to 34,000 hours. So for Sifa fabrication, it is very easy to calculate because our production also in hours, effective capacity in hours, and design capacity in hours. So very easy to calculate because have similarity of the unit. Okay, next. Okay, next I pass to Aziz to continue.
Hi, good evening, everyone. So today, I would like to present about discussion for our project proposal, where we have 3 objectives that we want to discuss in our project proposal, which is the first one. We want to develop strategies of reducing fabrication costs in order to improve productivity and profit of the company, where we can reduce our total inputs, which is total inputs come from our material and also fabrication costs. So basically, total productivity index is equal to total output versus total input. So if we want to increase our total productivity, we can try to reduce our total input. So basically, the first method that we can try in order to reduce our input is by reduction of material costs, where we can try to negotiate with our suppliers. Either we can get a few discounts if we purchase with bulk orders, and then we can only purchase the required material with proper minimum order quantity. In return, also we can reduce inventory costs together with the material costs, where we can only purchase with a small MOQ instead of big MOQ. And also we can try to find a very reliable suppliers where they can help us to ship all the raw materials within the time frame in order we can meet our customer deliveries. And last, we can try to reduce our packaging costs. So the second method we can try in order to improve our productivity is by reduction of fabrication costs, where we can perform audit operation and sufficient training provided for all the operators. Because by doing this, we can ensure that examples, the amount or the lead time taken by during the fabrications process can be reduced, or maybe we can produce more products within the time frame. Second, we can implement lean manufacturing techniques. Third one is we can evaluate and review back our production processes in order to reduce our fabrication costs. Next. So second objective that we want to focus is we want to reduce our lead time of fabrication process while maintaining quality of the product, which follows standard procedures. So means we want to reduce lead time at certain processes. So we can, from the slides, we can see that we got two portions that we can focus more, which is the first one is issuance of order received from the customer and also engineering design stages. Basically, both stages, because currently total days that we need, which is around 5 days, as you can see, we can try to improve to 3 days. Means that the lead time can be reduced to 3 days, which means issuance order received will only need 1 day to proceed with the customer order, the PO, and then processing customer design will only need 2 days. So processing customer design receipt, the teams must come with the someone expert with the designing software, how to read all the design received from the customer, so that we can come up with a very accurate designs. And then specifications of the design from customer also must be very accurate, so that the lead time for the team to come up with the design will not take any longer. And then, as suggested, also we can come up with the product catalogs with the specific designs that is most usually by our customer, basically, so that when customer comes to us with purchase order, we can just pass the product catalog to the customer, so maybe they can choose from there, so that we can reduce the lead time in designing processes. Next. So the second one is maybe we can try to combine packing stages with quality checking processes. Means after all the packing stages already completed, we can directly move or assign quality checking processes in the same time at the same place. So where the goods can remain on the packing side and there is no need to transfer to another place, while QC can be executed where the goods have been placed, and at the same time we can remove waste, remove the unnecessary movement at the same time. Next slide. So as you can see, after we already tried to perform those two methods by reduce lead time at certain processes, we can see that the lead time can be improved from 15 days to 12 days, where non-critical parts lead time can be reduced as long as it is manageable by those affected teams, and then shortening the completion days by performing project crushing at certain stages will help us to commit customer requirements and to ensure we will have buffer days if there is any downtime or issues appeared. So next. So the third objective that we want to focus and discuss in here is to increase capacity of fabrication to produce higher quantity and meet demand from the customer. So basically, first method that we can try to use is we can try to adjust our current equipment compatibility, means improvement of current machineries, And then we can purchase additional machineries so that we can commit the extra or additional demands. If let's say for certain products or certain SKUs, we can see that there is additional or double increment in the demand. So maybe we can come up with a proposal in order to purchase additional machineries. And then we can improve or reviewing our current process flow. Maybe we can try in regards to the market demand changes, we can try to dummy certain processes where unnecessary to remove unnecessary processes. Last, we can products or process flexibility. It means we can redesigning our current products or process flow in order to improve our feasibility to commit current market demand trends. Next. And then we can also using theory of constraint methods where we need to identify what is the current constraint that we are having so that either it is compatibility of design with the machineries or not. And then we can develop a plan on how we can redesign our products to make it more compatible with machineries. Maybe currently we have difficulties on how current design to make it more compatible with our current machineries. And then we focus on current number of resources, such as manpower and machineries, to come up with a proper plan. And then we try to reduce the effect of constraints. Either we want to increase the manpower, increase the machineries, and so on, so that to redesign our product, negotiation with the customer on the design availability and machines capability. And then once improved, come out with a new constraints. So maybe this is our first constraint, so we can move to another constraints. So basically this is a theory of constraint method so that we can try to solve one of the issues that currently we are having. So next I will pass to Risha for the conclusion. Thank you.
So as a conclusion, the focus of operation planning and control is the balance between the customer demand and what operation resources can provide. The goal is to connect supplier and demand in order to ensure that operation processes operate effectively and efficiently. So our first goal of the project is to reduce fabrication costs in order to improve productivity and profit of the company. And it can be achieved by addressing monthly material costs in order to develop strategy for reducing fabric costs. To begin, we can negotiate with the supplier, which results in a better deal and material requirement, such as bulk order, discount, and also prompt payment. Secondly, we can utilize the inventory software to purchase only the necessary material in the proper quantity that can help in stock need. And also we can find the dependable supplier is critical for the raw material. And also our second goal for the project was to reduce the lead time of the fabrication process while maintaining the quality. To achieve that, the sales team should be efficient and fast in addressing the order receiving and the engineering design stages. Providing additional training to the designing and the engineering team can help to complete these processes faster. So additionally, a product catalog with a special design for the customer and also include feasibility and compatibility product for the raw material can help to reduce the lead time and ensure everything is ready when the customer places the order. So in other hand, shortening the completion date through the project crashes can commit customer requirement and ensure buffer day in case if there's a downtime or a issue when there's a downtime or an issue. By doing so, this will encourage for a repeat business from our customer by gaining their trust. And also our last goal was to increase the capacity of the fabrication to produce higher quantity and meet demand for the customer. To achieve this, the company can adjust its equipment, improve processes, and improve product as well as process flexibility, adjusting the design capacity and reduce necessary stages to ensure the flexible process can help to increase the production as well as the downtime. So as a conclusion, right, the globalization of the market has been made it necessary for the business operation to adapt in order to remain competitive. So the OEM approach and manufacturing process of the company need to be evaluated in a various perspectives on a regular basis And the business are required to implement a set of new operation strategies and technology and innovation technologies, such as the JIT, just-in-time strategy, and also total quality management, TQM, flexible management, manufacturing system, FMS, and also such as computer integration manufacturing, CIM, lean production, LP, processes, business processes re-engineering, BPR, and quick response manufacturing, QRM, and also supplier change management, SCM, are some of the strategies that can fall under these categories. Next. So these are the reference that we refer to complete this project. So that's all from our team. Thank you.